Welcome to sublesson 9.2, where we'll use SSH for secure remote management of our Linux systems. SSH, also known as the Secure Shell, is a cryptographic network protocol for secure network services. I like to think of it as the administrator's Swiss Army knife. It's a really nice tool that you can use for securely accessing and performing functions on remote systems over the network. And it does a lot more than just logging you into a remote server. That's a really common use for it, is to log into a remote system and execute commands over that system. We've been demonstrating all that throughout this live lesson series. As we've been going by using Vagrant SSH, we're logging in over SSH to our systems, but it does more. It can do file transfer. For instance, I can use the SCP or SFTP commands to copy files from my local system to some remote system over the network. It also does port forwarding. This is a little bit of a complex concept to just explain, but if there's a port available to a remote system, a network port, that is not available to my local system, I can use SSH, an SSH tunnel. Basically, I can establish a tunnel to the remote system, and then I can, over SSH, access that remote port. So it gives me secure access to network services that I otherwise wouldn't have available. You can use the SOCKS protocol feature of SSH to web browse through an encrypted connection. So if I had an SSH server somewhere out there on the internet, I could use it as a proxy, and I could establish a SOCKS tunnel to my remote server, and I could browse the web securely, and it would look to remote web servers as if my connection was coming from the proxy server instead. So that can be really useful if you don't want anybody spying on your network traffic, for instance, or to help you get to web resources that you might not otherwise have access to. You can also use it as a secure remote file system through the SSH-FS file system protocol. So this will mount a remote system's file system over SSH to your local system. So I could start writing files to a remote server, and it looks to my server as if it's local. So those are a few of the features. Let's show how to configure and use SSH on the command line. So now I'm back at our network where we have a CentOS box on the left and an Ubuntu box on the right. So I'm going to log in from the Ubuntu box to the CentOS box. First things first, I'm just going to change my password on the CentOS box so I know what my own user account password is. Okay, my password is set, and now I'll SSH to bwhaley. I need to specify my username. By default, it's going to use the username Vagrant, and I don't want to use the username Vagrant. So in order to do that, I can say bwhaley @ or alternatively, I can do -lbwhaley. Use the bwhaley username to log into 192.168.10.10. That's my CentOS box. It says, what's your password? I can say my password, and now I'm logged in from the Ubuntu box to the other box. If I type W or who, I can see Vagrant users logged in from 10.0.2.2. That's this window, logged in from my laptop. And I can also see bwhaley logged in from 10.12. So that's the one I'm logged into right now. So that's a really simple example of using SSH. Now, that was using a password. I set my password on the CentOS box, and then I typed it in when I logged in here. So this is one way to do access control, but there's other ways that you might need to do access control. But let's check that out now. So I'm going to log back in out of the CentOS box back to my Ubuntu box, so I close the SSH connection. And now I'm going to generate a public-private key pair and use that to log into the system rather than a password. This can be a more secure way to access the system. So first, on the left side, I'm going to become, using sudo su-, I'm going to become the bwhaley user. I'm going to make sure I don't have any keys in there already, which I didn't, so that's fine. And now I'm going to generate a new key pair on this side. I'm going to make sure I don't have any key pairs on here as well. Great. So we can use the SSH -keygen, and then we specify an algorithm we want to use. Now, there is recently, due to events on the internet, some of these algorithms have been called into question. I can't say which of them are secure and which are not secure anymore. I'm going to go ahead and use the RSA algorithm, and I'm going to specify a 4096-bit key, which is probably more than enough, but it's the standard I like to use now. So it's generating a random cryptographic key pair. It's asking me what file would I like to save it to. I'm going to go ahead and say that. Now here it's asking me whether I want to use a passphrase or not, and this part's important. You can set up a key pair to not have a passphrase. This can be useful if, for instance, you have two different systems on the network and they need to do something automatically where there's not going to be a human there to type in the password. For instance, maybe there's a script that runs out of cron and it copies a backup file from one system to another. You wouldn't want to have a passphrase because there would be nobody to type it in. But for human use, anytime you're generating a key pair for your own use, you'll want to have a passphrase just for additional protection. I'm going to leave this one blank for now. So I'm not typing any passphrase. It's generated a key pair for me. Those are stored by default in my home directory, /.ssh. If we cat out our private key, if we print it to the screen, we can see kind of what it looks like. It's just a lot of cryptographic key garbled nonsense. It's not very readable to us. You'll notice that the size varies according to the bit length that you use when you use SSH keygen. We specified a 4096-bit length key pair. If you use 1024 or 2048, I would never recommend 1024, by the way. This will be shorter. In any case, we can actually use this. If we say SSH-I, ID RSA, -L, we still need to specify our user account, which is bwhaley. And 192.168.10.10 is our CentOS box. And notice that it logs us right in. Welcome to the Linux System Administration Live Lesson image. This is our CentOS box running over here. We didn't have to type in a passphrase or a password because we generated a passphraseless key pair, which, as we just discussed, is useful for automatic scripts, but is a little bit risky because if somebody compromised your key, then they could use your account without a password. So that's what it takes to use a public-private key pair. Getting the permissions exactly right can be a little tricky the first few times you do it. One thing to help you debug, if I revisit my same command, so this is the same command I used to log into the CentOS box from Ubuntu, I can add the -v, little v flag, and it spits out a whole bunch of information to me about what that key exchange. Sometimes this can help you. It'll tell you if the permissions are wrong or if there's some other problem with your key pair. Let's show another example of using SSH. So I have some file, echo hi, I'll output this. So I've got this file called file with the contents hi on my Ubuntu box. I can use the scp command to copy that file, and the syntax is source. The source in this case is file, and I can copy it to the CentOS box, 192.168.10.10, and I can put it in some different file, say /temp/ some other file. Oops, so I don't want to use the Vagrant user. This is what, well, it uses Vagrant by default. I need to use bwhaley, so I say bwhaley @ and it just copied it over there because the key pair is set up. So it copied a file from my local box, so now if I go into the /temp folder on my CentOS system, I can cat some other file, which I just transferred, and we see hi, so that was how I can use SCP to transfer files. Similarly, I can use SFTP to create an interactive file transfer session. So I could say bwhaley at 192.168.10.10. Now it's connected me to the remote CentOS system. I'm in my home directory by default. I can use shell commands to get around. So now I'm in the /temp directory. I can ls/home. I can get a file. Say I go to Etsy, I can get Red Hat-release. This is just like a release file that tells me what version of Red Hat I'm running. This wouldn't be present on an Ubuntu system, of course, since it's not Red Hat. Now that I've gotten it, I have it here in the directory that I was in, and it tells me it's a CentOS 64 box. If I go back to my CentOS system on the left and cat that file out, it's the same file. So this shows you how to transfer files around using SCP and SFTP. So I want to demonstrate one final example of SSH port forwarding that allows us to connect from a system to another system and access network services that otherwise would not be available. To demonstrate this, on the CentOS box, I have the Apache web server running. And it's listening, and we can see this with our netstat output. We can see that port 80 is listening, and it's the HTTPD service. So if we use the curl tool, we can see the HTML output. This would be rendered really nicely in a browser, but curl is a nice command line way to access servers. I can still use ping to talk to my CentOS system, so that network is still up. And if I try that same curl command from my Ubuntu system here on the right, 192.168.10.10, I can't access it. So let's use port forwarding to establish that connection. So the first thing I'm going to do is I'm going to bring up yet a third window in my terminal here. And I'm going to go to my work directory, and I will SSH to my Ubuntu box. I need two windows to demonstrate this. So on my top Ubuntu window here, I'm going to set up the port forward. So I'm going to port forward my localhost port 8000 to the remote host's port 80, and I need to then log in to the host. I need to specify my username as well. Okay, so now I logged in from my Ubuntu box to the remote CentOS system, and I'm doing some port forwarding. And so let's look at that on our bottom window here. If I look at my netstat output here, I show that here's port 8000 listening. This wasn't listening before, and it says that SSH is using it. All right, that's what we're seeing here. So port 8000 on my local system is mapped to port 80 on the CentOS box. And now if I curl my localhost port 8000, I see the same HTML output. So this allowed me to map my local host's port 8000 to the remote host's port 80. And this can be a really useful feature for accessing remote systems that might be behind a firewall, for example. So let's take a quick look at the SSH configuration on my CentOS box on the left side. If I cd to /etc/ssh, there's a few files in here. We see the SSH server's public key fingerprint. We see some other information. SSH_config is the client configuration, and SSHD_config is the server configuration. If I look at this file, SSHD_config, I got permission denied. I need to use sudo for that, sudo bang bang. Here's all the server config, and the nice thing about this config file is it's very verbose. It shows us there's a lot of commented out sections. So we can see, for instance, it's listening on port 22. If you see a hash mark in front of a configuration item, like any of these lines I have highlighted here, that indicates that that's the default. So you could uncomment it and change it to, say, port 25, which is very non-standard. But by default, it's going to be port 22. It's only allowing version 2 of the SSH protocol. Version 1 is insecure, and you should use version 2. And there's all sorts of other configurations. Here's a couple important ones to point out. One is this line here, permit root login yes. This is commented out. By default, it's permit root login is no, and you should leave it at no. We don't want to allow root to log in. We have password authentication set to yes. Often you'll see password authentication set to no, which means only allow public-private key pair authentication, which we demonstrated just a minute ago. Often cloud systems, like for instance Amazon's web servers, will not allow password authentication. They'll only allow public-private key pairs. It's a more secure setting. And there's all sorts of other configuration you can add here. In general, just like securing any Linux system, you should disable anything you don't need. For instance, I might disable X11 forwarding. X11 forwarding no, because I just don't need it. If you need to make a change, you have to restart your SSH server. But here's a catch. If you make a change and you've made a configuration mistake and you try to restart SSH, you may lock yourself out of the remote system, because SSH will try to read its config and restart, and the config will fail. So just be really careful about how you handle that. So that's the basics on configuring SSH on a Linux system.